I'm going to explain this question, which is longest palindromic substring. So what is the input and output in this question? Very hard question. So you are given a string like BABAD and you have to find the substring. So substring is a part of a string, right? Which is longest of maximum length and is palindromic. So what is palindrome? A palindrome is when you take any sort of string and it's same from backwards and forward also, from backward also and forward it is the same. So like you see BAB. So if I for example, like I write B A and then B, so is this palindromic? So for example, I just cut this in middle. uh you can see like this and this is same, this and this is same, like BAB. If you go from forward it will be BAB, if you go from backward it will still be BAB, right? For example, if I take BABA, so then is it palindromic? Yes, it is again palindromic, because if you go from forward it is BAB, and if you go from backwards also the string is B. The string is uh now this forward and backward is the same. So you can see like for example, B and A are the same. No, they're not same. So this is not palindromic. BA is not palindromic because forward and backward is not the same. For example, it was B and then A, which is BAAB. So is it palindromic? Yes, you can see this and this is same. Like if I place any two sort of pointers, you can see like this and this is same, and this is also same. So of course this is palindromic, right? So if you see from forward it is BAAB, and if you see from backwards it's again BAAB. So it's palindromic, right? So this is what they're saying. This is palindrome. Now you are given here in the question like a string. Like you can see the string is like B A B A D. Now you can generate a lot of substrings from this, right? You can generate B A, you can generate two length substring, you can generate three length substring like B A B A B A B. Then you can generate also four length, which is like B A B A. So there are a lot of possibilities. Now you have to find like the longest substring. So for example, if you even generate B A B A, so this is, so you can see like this is not a substring which is a palindrome. This is a substring which is palindrome. You can generate a lot. So you have to actually tell the maximum length. So the maximum length longest palindrome is what? This BAB, right? This you can see the output is BAB because this is actually the longest palindromic substring in this string S, right? And also you can see BAB and also ABA, this one. This is also the longest palindromic substring. Again, there's another example given. Here BB is the longest palindromic substring. Now given, of course, in any question you're given like sort of constraints. So the constraints here is that it is between 1 to 1000. So you know that like in a lead code online, like for coding this on lead code, like on such platforms, you have to, you have like 10 raised to power 7. You can perform 10 raised to power 7 operations, or you can say 10 million. You can only perform 10 million operations per second, right? You can only perform 10 a million operations per second. So if you do this, sort of provide a code which is basically n cube, will that satisfy, will this constraint be satisfied? Because n cube will be 1000 into 1000, 1000 three times, right? So that will definitely be very boundary case, and that can give you a TLE, because you can only perform 10 raised to power 7 operations per 10 raised to power 7 10 raised to power 7 operations per second, right? So given this constraint, it is obvious that you have to give some sort of solution in like n square, right? This is kind of like something that you can understand from the constraint itself. and the string has only digits and English letters that is given. So you know this sort of table, like if it's 1,000, you give it, like you sort of give, uh, basically you give n square, right? And if it's 100, you can give n cube. If it is 10 raised to the power 5, go for n log n. 10 raised to the power 6, go for n. 10 raised to the power 7, go for n. So after 10 raised to the power 6, it kind of gets very strict because you can only perform 10 raised to the power 7 operations in, 1 second. So 10 raised to the power 5, it is n log n. But in 1,000, you go for n square, right? And 100, you can go for n cube. 100 is very lenient, you can perform because you can perform only 10 raised to the power 7. So solving this question can be through with various approaches. I'm going to explain you one approach by one approach. So the brute force approach that will genuinely come into your mind is like, it's very intuitive that you generate all the substrings. Like I was helping you generate here the substrings, like for example here BABAD is given. You can generate any length substring. You can generate one length like B, two length like BA, three length like BAB, four length like BABA. So generate all length substrings, and then what you see is that for each substring like BAB, like a BAB is a three length substring. You check, is it a palindrome, and how do you check if it is a palindrome? Like for example, you have a string like B A B. You generated the string, and now you have to check like whether it's a palindrome or not. Very simple. You just take two pointers, one on the start and one on the end. You can name it like left or right or start or end, whatever. And then you just see, is a string of left, that the left and right pointers, wherever they are pointing, the string is the character, actually, sorry, the character, it's same or not. If it is same, then of course you move. And like here, just it's odd, or like you can just see like this is same here also and here also. Like for example, it was B A A B, like it was like this, and you had to check like, is it a palindrome? So you see left and right pointers. Okay, this a palindrome? Yes, this is a palindrome. Then you see, move here, then you move left, then you move left plus plus, right? And then what you do, you do right minus minus. Right was on the end, and then you do right minus minus, and then check, okay, is this equal? Yes, this is equal. That means this whole string is only palindrome. So this is sort of like code that you can see. What kind of code they have written is that, what kind of code they have written is that, yeah, just a second. Yeah, I think this, nope. Okay, so what kind of code they have written is like, as you can see, class solution. So you obviously write any sort of code in class. This is the entire code, and then this is a, like, you have written public only. So you are given like a function. So first, the above function is checking whether it is a palindrome or not. So you pass the, like, parameters like s, which is a string, left and right pointers, right? Left pointer pointing on in the extreme left, and right on in the extreme right, right? And then you put a while condition. So why we are putting while condition? For example, you write B A B, and then you put left and right here, and for example, this left somehow crosses the right. Now this will go out of bound, right? We don't want this. That's why we always say that left is always less than right, because that way left will not cross right, right? It will remain in bound. And then you just check that the character on left and character on right, like, so you can access it by s left and s right. Are they equal or not? If they are not equal, you just return false. And if they're not equal, you move, uh, If they're not equal, you just return false, and you also move. So you move left plus plus and do right minus minus, as I told you. Otherwise you just return true, because if they're not equal then it's false, and otherwise it must be equal, right? So what you did here is like check palindrome. But before checking palindrome, of course you have to generate the substrings. So to generate the substrings, what you can do is like do it using obviously two you can do it like using two for loops. So for example, b is given to you. Sorry, we can just take this example, right? b a d, we'll just take this one only. So b a d, you can see like you can generate so many substrings. So if you start from b like this, so you can go from b, then you can go ba, then you can go bab, you can go ba, then you can go ba, so if you start from b, this will be the possibilities. Now if you start from a, then possibilities could be a b a, right? A b a, or a b, right? So there could be a lot of possibilities. So what you're essentially doing is that you're pointing, like for example, I here, and I will iterate till the last, till n. And then where will be the j? J will be j will be at I initially, like j will also point here only, and it will also go till n. But then after, like, so this is the first iteration where I and j are equal. So I will be equal at 0th position, and j will be, so this is the indexing, like, right? So in cpp, like, strings are like sort of stored in array only, right? So the indexing is from 0. Now like b a b a d, so this was like given to you. And what we initially did was that I and j was at 0. So now I, he's here, and then obviously first string was b and the second string is ba. So how will you generate? You will obviously move uh, j here, right? Then you will move j here. So for every I, you are moving j. For every, like, if you're fixing this b and then you're moving this j. uh okay. So for I equals to 0, you'll move j. j j will start from I, and then j will just move. And then as soon as I will become come at here, I will come at one position, then j will also start from this only, right? And then when you start from here, it will then generate all the substrings from starting from a, like a b, like that, right? So what you do is write two for loops. And then how will you check? So you wrote the function to check palindrome above, so you will just do the call. And inside that you have to see that okay, what will be, so because you have to generate the substring with maximum length. So for that, what you'll do is like see the current length. So what is the current length of ba? The current length is nothing but, so I will be here only and j will be here. So if you do j minus I, so because it starts from 0, so 0 and 1, so j minus I, so j is basically it's index only, right? So j minus I is 1 minus 0 is 1. So is the length 1? No, it's not 1. So it is 2, right? BA is length 2. So what you do is you write j the current length will be j minus I, and then plus 1, because the length you want is 2. So you have to do plus 1 in all cases. So that is current length. So current length is the current length of the string. Whatever string you generate, that is the current string, and that string's length is the current length. So that is j minus I plus 1. Okay, now you have to, okay, so here we can see like, okay, this is 2 length string. Okay, now then there is 3, so b single, then, and this is 1 length string, right? And then this is 3 length string. Now you see like b is a palindrome, right? A single string will be a palindrome. Then bab is also a palindrome. Now current length first was like 1, right? Then you found another palindrome which is 3 length. So then uh basically like you make the best length as 1 only initially. So these two variables you have to initialize, which is start, and like the start will point at the start index. So why you putting the start at 0? Because you want to have the best start updated again and again. So if the start best start could be like from B only, like BAB, or it could be also from A, like it could be ABA. So you have to update the best start later, according to wherever the best longest palindromic substring is found, right? And you have to also have a best length, because that then you will update, okay, by comparing. So the current length right now is like 3, right? So you have to update the best length or the current length, so you will compare, okay? So current length, you'll compare the current length and best length. So like the current length here is 3 and the best length was initially initialized, that we have already initialized as 1. So obviously 3 is greater than 1, so you have to basically, because so obviously that means that BAB is a longer palindromic substring than the previous string, right? So you have to update it. So for updating it, so we put a if condition. So if current is greater than the best length, you will update the best length as the current length, and you will also update, you will not just update the best length as current length, you'll also update the start. So the best start, you will update at whatever index you are starting at. So best start is equals to I. So this is something that will remain same in the other codes also, that I'll tell you. So you have to just compare, but do a very simple comparison, right? And now, because you know the best length, so for example, you know that the best length is 3, so 3 is the best length. So and you also know the best start. So best start is, for example, starting from this, the 0th index itself. So you have to print the substring from 0 to 3, right? So 0 to 3 is what? 0 to 3 is BAB. So that is your palindrome. For example, if it was, the best start was from 1 and the maximum length was 3, or the best length was 3. So the best start comma best length would be 1 comma 3. So that means 1 comma 3 means nothing but you have to print from 1 to 3, and 1 to 3 is what? It's ABA. ABA. So that is what? That is also a palindrome, right? So here you can see that here in initially question, you could have BAB also and ABA also, that both are valid answers, right? So you have to return s dot sub str. So this is like you have to use this function, and you have to pass in the parameters as best start and best length, right? Because that is only how you print. So you do sub str, right? Sub str. So that will help you basically print the substring of the maximum sort of length, which is palindrome, right? Then this is like the brute force. What do you think would the time complexity will be? Of course, the time complexity will be n cube, because here first of all using two for loops, right? That only is giving you n square, and then you're also basically checking the palindrome thing and also updating. So that will also take n time, right? Checking of palindrome, because you have to iterate and see, okay, this is here, see that, okay, is this palindrome? So that will also take n, and generating the substrings, so generating all possible substrings will also take n, and the palindrome checking will also, so generating will take n square, and this will take n. So that will be n square into n, which will make this the time complexity of n cube. So that n square into n, so that is why it will become n cube, right? Because generating all possible substrings with the help of two for loops, right? So your the thing was very simple, and the space complexity will be what? The space complexity will not be anything, because you're not having any vector or anything. It is will be big of 1. So what you're doing is generating all possible substrings, and for each substring you're checking whether it's palindrome or not by 2 pointers, and also tracking the maximum length of the palindromic substring, right, by current length, and by maintaining a best length variable, and then finding the current length and then comparing the current length and the best length. And also you initialize the best start at before best start and best length, right? Now the better approach would be sort of like a very standard yet better approach would be of recursion, right? So what you do is in recursion, you a function calls itself, right? Keeps on calling itself. So it's like, for example, if a book, you have to read chapter 10, so you will call function chapter 9, then you will call function chapter, so if you read chapter 10, right, you will call chapter 9, you will call chapter 8, then you will call chapter 7, 6, 5, 4, 3, 2, 1. So till you reach 1, you keep on calling, and that is actually the base condition, where afterwards this is the base, it can't go any further downwards. So this is the base. So yeah, so basically this is what it is, right? So you can see the code. So what we have done is here, it also is maintain the best start and best length that initially also we did. So here what you're doing is, like, again, like you can see this example, like a b b a, right? A b b a. So in ABBA, what is actually sort of happening is, right, I'll just show you here. So like ABBA, you can see, like, you first of all call from 0 to 3, okay? So you basically sort of write like a function of checking palindrome. So recursive function you have written, which is bool is palindrome, and you've passed just left or right to check whether the substring or whatever the string is palindrome or not. So you do simple thing, like the base case would be like, obviously the left should not cross the right, because if left crosses the right, right, so for example, this is left and this is right. So what you do is, like, the left and right are equal, then it's palindrome. If it is not equal, the ends characters of both the ends are not matching, then you're returning false. And also the base case is that the left and right, so if the left and right, if left is greater than right, left is greater than right, of course it is. If left is greater than right, or so left is like, for example, left becomes equals to right, so that will be single string. Is it a palindrome? Yes, this is a palindrome, right? So, and if left only just, there is no like string, like if it is just an empty string, so if left only crosses right, right, because otherwise right should be always forward from left, because left pointer is at extreme left and right as at extreme right. Now if left will only cross right, that is also the base condition, so base condition will be 2, right? You reach at either a single string or at an empty string, and that is why both of them will be the base case. And what we are doing is that we're shrinking the problem, right? So what you do, first call, like, for example, this is 0, 1, 2, and 3, this is the indexing, right? So what you do is, first you do function call of 0 comma 3, is you do function call of is if 0 comma 3 is palindrome or not. So you check, is this a palindrome? So for that, what you do, you call 1 comma 2, you call 1 comma 2. Now for checking 1 comma 2, what kind of function call you do? Then you call 2 comma 1, because when you call 2 comma 1, that is that basically means that left has crossed the right, right will come here and left will come here. Left has crossed the right, and when left has crossed the right, that is the base condition, that left has crossed the right, that means that's just an empty string, because there's nothing left, right? You have crossed the right. So that is how the base case will be reached. Then it will just go and sort of like backtrack, right? So you can see, like, I will just show you here. Like, initially you check in AA is same, right? At 0th and third position is same. Then you do function call of 1 comma 2, then BB is also same, and then you cross. So that is also true, you automatically return true because you hit the base case. Because when you hit the base case, you have just written here that whenever you hit the base case, you just have to automatically return true, because you reached the last position, right? You can't go any further after that. So then obviously, to check its palindrome, you're shrinking the problem. How are you shrinking it? You are moving left forward, and you're moving right one step backward. So left plus plus and right minus minus, or you can say left plus 1 and right minus 1, right? So this is how, this is the function of checking the palindrome. And inside, so this is what it's given in the question, right? There would be a class public and there will be just a function given. So function given is string longest palindrome string str, right? Or string s, right? So what you do is, basically, then you do the same like you did in brute force. You generate the substrings, and here like you check if it is palindrome or not, right? Initially you check the palindrome thing through the iterative way by writing just a while loop. In the while loop, like you can see, this was a brute force, right? You can compare also in the brute force and this recursive, what is the difference. You just were comparing the characters from both the ends, and then you were checking. So this was a function that you were using, and you were just of calling this function here, right? And the function was written iteratively. Here the function of checking the palindrome is written what? Recursively. That is the difference. The downside is pretty much same, where you're updating the best answer because you need the longest substring, right? You have checked its palindrome or not, but you need the longest one. So you maintain like the best length and best start above only, and then you calculate the current length and then compare the current and the best length. So if the current length is 3 and the best length initially you set as 1, obviously you will update the best length as current length, right? And then you will update the best start, which is at the starting index. So the starting index here is like left, right? So you will update best start is equals to left. I hope that it's pretty much understandable. Yeah. So here I kept ij, but here I have kept left and right throughout the code. So that is like a better code, you can say. Uh, or maybe if you understand to that, that is also better. And simply you have to remember this, that you have to return the substring from like 0 to 3, because like the best start could be like from the 0th index itself, and the best length would be 3. So best start comma best length, or maybe if the best start is at 1, like if you're starting, for example, the best start is from bb, if it is bba, for example, you have to generate bba, so that will be 1 comma 3, because the best start is at 1 and the best length string is 3 length. So yeah, so that is like the recursive code, right? Now of course, when recursive code comes, there's a simple thing that things go in the time complexity of 2 raised to power n, which is basically very exponential. And also because in memory recursion takes up stack. So because in stack you fill up elements and you are pushing and popping things, and you make function call again and again and again, and it can go like to infinite also, like you keep calling function again and again and again until you reach the base case, right? So that will take up a lot of space, right? For big kind of function, like you'll keep calling until you reach base case. That will take a lot of space, and also the time complexity is 2 raised to power n for recursion, right? So automatically the things come to dp, because dp essentially is dynamic programming, and it is like optimization technique where you optimize the code. Why do you need to optimize? Because you need to fit in the time complexity and the space complexity, right? And what dp essentially does is that the dp thing does is calling, it says that call a smaller function, call or solve, not basically it says that you have to solve the smaller sub problem, and automatically the big sub problem will be solved. Like some sort of analogy that you can think of is like you have a big problem, right? And what you do is that you solve the smaller part of it, like you solve this part of it, and then automatically, because you solve this small problem, the whole red problem gets solved. Like this, you solver problems, and then the big problem will get solved. Focus on the smaller, solving the smaller subproblem. That is what dp says. And this is what dp wants, that you solve the smaller subproblem to solve the bigger subproblem. And also there's another thing that it does, is that it maintains a sort of a vector or an array to save the things which are already computed, because you saw in recursion that sometimes when you make the function call, it is very repetitive. It is very repetitive. There is a lot of repetition when you talk about recursion. And to avoid that repetition, you maintain a vector or an array wherein you store, like for example, if you calculated something for index 1 and that was probably like 1, so you will store that in a vector at probably index 1, uh, and you'll store as 1. So initially you will store -1 -1 -1 in the entire vector, and then whatever you have computed you will start updating here, because other when next time the same function call is made, you will go at this vector only and see, okay, at index 1 is it already stored? Yes, it is already stored, and then you will retry from here. You don't need to make a function call again because you have already computed it inside a vector. And this is how your like time complexity and space complexity gets saved, right, by maintaining a sort of vector, right. So initially, to optimize recursion, you can go for memoization. Memoization is just a step ahead of recursion only. So for example, this is memoization code. So I'll just simply explain the example. This is also known as top down DP, because you just doing recursion, and recursion is top down only. You because you see, like I told you, like if you start from chapter, you want to read chapter 10, you'll call chapter 9, then 8, then you'll go till 1. So this is top down, right? So that is why recursion is one thing, and on the top of it only, that is memoization. So memoization is very much similar to recursion only. You just need to add 2 3 extra lines, and then the code is itself memoized. That's it. So you see here that dp left right will store the result for uh, s left and s right. That means the string, whatever substring you see, you will need to maintain like sort of like a dp, like a vector dp, which is a 2d dp here, because you will store, like for example, what is like a 2d dp. So if I make 1d dp, that will be just here, like this is 1d dp, like you just have an array, simple array. And if I say 2d dp, it is in a form of like a matrix. So this is like 2d dp, right? So for example, b a b, so you see ab, so that will make the string ab, right? If you see ab, this will also make some string, right? So that is how like sort of like a matrix it will be stored, right? This is like, so in this question, for the longest palindromics substring, you will make a 2d. So the here, like left pointers will be stored, and then your right will be stored, right? So yeah, that's it. So we'll just show you. Here you can see, so you can see here, this is the bottom of dp solution, and this is dp solution, and then yeah, this is the dp solution. So you can see that you have written the same recursive code of checking the palindrome thing. This is exactly the same, that if left is crossing right, or it's just as empty or a single character, then just automatically return true. And this also, if the characters are not matching, then you have to return false. So here you will just basically return dp, so you will compute. So if it is not basically matching, you will compute here as 0. You will compute here as 0. For example, a and b was here, and because they are not matching, you'll compute here as 0, right? And you will just return dp left right as 0. Then to call the smaller one, so when you have checked 1 comma 0 comma 3, you call what, you call 1 comma 2, right? You call 1 comma 2, right? You see, like b a b a, you like you if you have b b a a b, you call this from 0 0 to 3, and then you basically reduce this, you go to 1 to 2, right? You do the smaller substring call. So for that you have to also compute the call whatever. So you computed 0 for 0 comma 3, yes it is. So for example here 0 1 2 3 will be there. So here also 0 1 2 3 will be here, and 0 comma 3 means 0 comma 3. So here, because it's a palindrome, you write 1, and then you do another call, like you do 1 comma 2 call. So 1 comma 2 is also a palindrome, you will write 1 comma 2 as 1 here, right here. So you will store left and right pointers indexes here, 0 1 2 3 0 1 2 3, and like maintain a table for that, and then compute here. Because the next time you do 0 comma 3 call, you're just seeing, okay, this is a palindrome. You see 1, yes, 1 means it's a palindrome, 0 means it's not a palindrome. So you are maintaining this. So to make this sort of a dp, you will write vector vector in dp, because it's a 2d dp. So we'll write, if it was vector in dp, it will be just 1d dp, but if it's vector vector in dp, then it's a two dimensional dp, right? 2d dp. Now this is how you do. So what new thing that you can see, I'll just highlight, that is there in the memoization code. This return dp left right here, here, and then you can see here, and also you can see here, right? So basically you make this dp here, right, and then you return. If so, this is new, this is actually new. So it, if it is like, if here -1 is stored, that means this has not been computed, and you have to solve this. So you have to see that if it is not computed, then you have to solve this. And if it is not equals to -1, of course it has been already computed. Now for example, this is not -1, this has been computed, so you have to return that dp, whatever the value there is present, right? So if it's already computed, return that, and if it does not match, put 0, and then do the smaller substring call. Now this will be the function that will be given. This is another thing that dp has to, you have to initialize this as -1. So you write here that dp dot assign n comma vector int n comma -1. So n comma -1 is, that means that the entire 2d dp initialize this like with like -1, like each entry should be initially -1, right? So uh, then you have, again, you're maintaining the, this is same, like the best start and best length you maintain as 0 and 1, and then you check all the substrings. So you again do that for looping thing, and then check and also see that if the current length is greater than best length, you update it. You have to compare which length is better and then update it. And then of course this is the most important step, where you have to return. Of course you have to return what you have to return, the substring, because it was the longest palindromic substring, to return from the best start to the best length, right? So in the dp you see this, only one line of code is there in the function, and the function of palindrome, only 2 3 extra lines where you write the vector in dp to make the 2d dp. Then if it is already computed, you return that, and if it does not match, you return dp left right as 0, and if uh, it is there, then you store, you solve smaller substring and store the result, right? So this is the code for top down dp or memoized code. Okay, now this is bottom up dp. Now what is bottom up dp is, now you want that, what do you want? You want that you don't want to do recursion, right? This is now you want what you want. So you here, what you are doing is that you are sort of making again a 2d dp only. uh okay, and then you're solving, like there will be a question like, okay, like again this string will be given to you, like the string was a b b a, right? And what was the index? It was 0 1 2 and 3. So you solve for one index, for 1, right? For the length 1 you solve, and then you solve for the length 2, like, so for what is the length 1 substring? It is a b b a, this is length 1. Then say you generate length 2, so it's AB, then it's BA, right? This is length 2, then also BB, right? So what you do is that you basically store in the grid only or the DP only of length 1 and length 2. You store for length 1 and length 2, and then using the length 1 and length 2 you calculate length 3, length 4, length 5. So you store of only length 1, you store only this length 1 and length 2, already you store, right? So you are building the answers from the smallest substring, because 1 and 2 the smallest substring possible from the ABBA string, right? So building the answer for length 4 or length 3 from the length 2 and length 1, because from length 2 and 1 you will build length 3, and from length 3 you can build length 4 also, right? So you doing the same thing only, but you're doing this iteratively. There you were doing recursively, here you're doing iteratively. Now you can see the code. The code has the same thing, that you are basically making vector int dp, or maybe like you are doing you can make it like this also, where you having like vector bool dp, where bool means that you can only store 0 or 1, right? And that has n vector bool n comma false. That means initially you put in 0, right? Then base case is that, of course, like you just iterate, and dp I comma I is true. That means if it is like 1 comma 1, that means only one string, right? So that means that is true. So single characters you will mark as true. That is a base case. And then for length 2, so you did this for length 1, and then second step you have to do compute is for length 2. So for length 2 you say that int length. So initially uh, you have to make two variables, set two variables like best start and best length, because that will be the substring from best start to best length. So to calculate the length for the 2 one, you will calculate for int length equals to 2, length less than equals to n, length plus plus, int left equals to 0, left plus length minus 1 is less than n, left plus plus, right? So left plus length minus 1 is less than n, and then int right will be left plus length minus 1, and then you're doing the same thing. You're checking the matching the characters if it is matching. So if length is 2, then you have to just return true, okay? If the length is 2, and else you have to call the bigger one. So if 2 is already computed, then you call 3. So you do left plus 1 and then right minus 1, 3 comma 2, right? So you do 3 comma 2. Else if it is not there, then left right is false. So if it is not, then 2, and you call it does not return anything, so it is 2. And then updating you have to do. So updating will be that the dp left right, and the length will be greater than best length. Update the best length as the length that you calculated, which is like the current length. So current length you're calculating here, right? Current length is you're calculating here. So yeah. So here you update it, and best start will be left. So you see this one, right? We'll just try to do this like a b b a, right? So what you do is do for simple string. So you start from I, and I will go till n, and you maintain a sort of a grid, wherein in grid you are updating for dpii is equals to 2. That means single substring will be marked as 1. Now length is 2. So length is 2, that means length is less than n. So you iterate throughout. For left equals to 0, so left equals to 0, left will be at 0th only, and you have to move right, and right will be at the extreme. So left plus length minus 2, right? So left plus length minus 1 is like left, for example, left was here, and so yeah, left was here at 0th, and length is 2, so 2 minus 1 is 1. So that means here only, so you have to see AB only, right? So you have to move till left plus length, right will be just till left plus length minus 1, because you have to generate only two lengths substring and then check if it is palindrome or not, right? So then you see, first you match that left and right are equal or not. If they're equal, and then you go in the if condition of length is true, and if it is length is true, then you have to just return true. And if uh, length is true and there is there, right, so you return true, and then else condition is that you have checked for length too. So basically, like, if you like check for BB also, right, so BB is a length 2 and it matches, then you check for ABBA, so you increase, right, you sort of like expand. So now you will, what you will do is, then you will call, you will go for the checking DP left plus 1 and right minus 1, right? So you're solving sort of like the smaller substring and then seen for the length 3 and length 4. So that is what they have done. uh yeah, pretty much it. For me personally, I don't like the bottom up. I like the top down because it's more intuitive, because you have to just write recursive code and then just see these things. So all of these codes, bottom up and so bottom up will obviously take a time complexity of n square, because you are making like a grid, and also you're computing also the n square for computation, and for this also making also. So that will be n square plus n square will be n square, so time complexity will be big of n square, and the space will be also n square, because you're making a matrix, right? You're making a vector in dp, or vector bool dp, so that is n square space wise also. For memorization, big of n square, the time complexity again will be big of n square for memorization as well, right? So this will pass, but the space is again taking big of n square, because making a grid in dp. So you, if you can somehow decrease the space complexity, time complexity is fine. If you can decrease the space complexity, that will be very nice. So then comes this newer kind of approach, which personally I found it very interesting, which is expand in center, right? Which basically means, like, for example, you have this string, sorry, BAAB, right? What are you gonna do? Or maybe you have a string like BAB. So what you're gonna do is that you are gonna make cut in the middle. So for example, BAB, you cut in the middle and then you check left and right, are they same? Yes, they are same. It's a palindrome. So basically, it could be a odd length string or even like an even length string, right? So, and even in the string, so for example, B A B A, so this is 0 1 2 3 4, so 0 1 2 3 and 4, this is indexing, and this is the 5 length, this is 5 length, that means odd. So you can cut this from the middle and then see, in the, so this A and B, this is map. So while you see B and A, so you see A and B does not match, so you see first this one, right? You see this one, and then you can expand from the center only. You can expand the window and see, okay, this also does not match, this only does not match, then you need not check the big one, big window, if the small window is also not matching. Now for example, it was B, then if it's B is A, then A, and then A, and then there is B, right? So this is 5 length, right? Now you cut this, now you see this one, is this a palindrome? Yes, this is a palindrome. Then you see the big window, is this a palindrome? Yes, this is a palindrome. You see this and this is same, right? This is palindrome. So you expanding the window from the center, and that's why the approach is expand in center, and you're not taking any sort of vector or anything, so there is no space complexity here. The time is big of n square, because you have to do the same thing, but the space will get optimized into big of 1. The space, this is for the space I'm talking, not the time. This is space complexity. So you sort of see the code, you are given the function. So if there is nothing, like there is no length string given, if it's an empty string, if n is 0, the string, there's the string size is 0 or string length is 0, then you have to return an empty string, right? And then you have to maintain the start, best start and the best length. Here I've made the variables start and max length, that is just the best start and the best length, because at last you have to return the substring from the best start and the best length. Then what you do is you simply apply a for loop. For the for loop, what you do is that you just simply apply for loop and have a left and right pointer. So for example, here the string could be odd and could be even. So this was a case of odd, right? This was a case of odd because 0 1 2 3 4. So the indexing is still 4 and the number of characters are 1 2 3 4 5. So this is, it has 5 characters, which is odd number of characters. And what you can do is just compare. So if for example this is I, you can compare I, this is the I, this is center one, right? So I plus 1, I plus 1, right? This is I plus 1, and this is what, um, so this is I minus 1 and this is what, I plus 1, right? So you can compare I minus 1 and I plus 1. So left and right will point at I, left will point at I minus 1 and right will point at I plus 1. This will be a case in odd, right? And in case of even, so in case of even, like for example b a b, right? So you are at, for example, this index, you cannot have a center here because you cannot have a center here. Like here, if you have a center, you can skip this character and see at the left and right, but here you can't skip. So you are at this position, at this position you are. So you have to see what, you have to see I plus 1. This is not matching. For example, I was here, right? So for example, your I was here, right? So you have to just see I plus 1, you have to see I plus 1, the next one, right? So if left is at I, then right is at what, I plus 1. Just match left and right. So you, in case of even, you make left as I and right as I plus 1, right? And then that is for the odd and this is for the even. So you do for both odd and even. So for odd, you will initialize left and right by, you will iterate first, make the left and right. So for you have to make a for loop, because for loop, inside for loop you'll write the whole code of odd and even, that this will be inside the for loop, odd and even. So for the odd one, you will make left as I minus 1 and right as I plus 1, and then you will have a while loop. In the while loop, left will be greater than, obviously left is gonna be greater than 0 and right will be less than n, right? It should, left and right, this condition is a simple condition that you need to have, and also left and right should be equal. And if it is equal, then you write the updation and comparison of current and the best length, right? So if the current length is like 3 and that is greater than the best length that you, or maximum length that you initialized as a variable initially, then you have to update the max length as the current length. And then also you have to make the start, update the start is equal to left, because you have, if for example the string is aa, that is the, maybe the best answer, so you have to update the start at one, start not from 0. Initially start was 0, you have to update start at left because left is pointing at a, so start will be left, right? And then what you do is that you move left plus plus, left as minus minus and right as plus plus, right? You don't do left plus plus or right minus minus, which was you would, because initially the other approaches of, brute force or something, you had left here, right here, so you moved left plus plus and you moved right right minus minus, right? So that you did in the brute force. But here the approach is expand in center, so you are starting from the center itself. So like for b a b b, so for b a b b, what you're doing is that here and here it is there, right? So now left will be, left will be what, left will be minus minus, and then right will move forward. So the right will be plus plus, because initially you solve the smaller one, now you'll solve the bigger one. So here the smaller one is not the palindrome, so you need not check for the bigger one, but I'm telling you like that. I hope that you understood, right? So you have to move the pointers also. So that is for the both odd and even. Even also the same thing will be there. It is like the exact same code for even. Just the difference here is in the, like this and this is different. Left and right is different. Exact same code for updation, right? But left and right where they are pointing is different. After then you have to return the substring starting from the best start and the best length. The time complexity is big of n square here also, because inside the for loop you first iterating it throughout the string, and then inside the for loop you're doing computations for odd and even. So that will be n into n, right? It could be the string could be odd, that will also take n. If or the string could be even, that will also take n. So n into n will be n square, and that's where the time complexity is n square. But the space complexity is bigger of 1, because you're not making any additional vector or anything, right? You're not making any additional vector. Like in the dp you were making the 2D dp, right? You're making like a matrix where you're storing the pre-computed things. Here you're not doing this, so that's why the space is better, and hence this approach is like the best approach from the brute force or the DP approach. The name of the approach is expand and center. There's another approach that will just take big O of n time complexity and big O of 1 space complexity. So for that, there's like an algorithm that I can show you guys, which is this one. So this algorithm, which is manager's algorithm, this basically is going to, you know, give n big O of 1, right? So yeah, I can explain this in a new video, but this is not exactly expected, maybe in an interview. But yeah, that's it. You can read this sort of article. This is a new algorithm, and this is the most optimized. This is in big O of n. This does not require big O of n square. So yeah, that's it, guys. uh I will just end this.